Ever wondered what it would really be like to face the dangers of space? Beyond the Hollywood version of laser beams and little green men.
Right.
Today, we're taking a deep dive into an article titled Six Ways Space Can Kill You, besides aliens, to separate science fiction from reality.
Sounds fun.
Get ready to uncover some surprising truths about surviving in the cosmic wilderness because it's a lot less like, well, Star Wars, and a lot more like surviving a trek through Antarctica, but with a lot less oxygen.
That's a great comparison. The article does do a good job of highlighting those subtle, persistent dangers that are just as important as those big catastrophic ones.
Right, like freezing in space. In the movies, someone gets sucked out of an airlock and instantly turns into a human popsicle. It makes for a dramatic scene, but is it actually accurate?
Well, space is incredibly cold, close to absolute zero, but what a lot of people don't realize is that it's also almost a perfect vacuum. And a vacuum is a terrible conductor of heat.
So you're telling me I wouldn't freeze instantly. What happens instead?
You would lose heat, but primarily through radiation, which is a much slower process.
Okay.
Imagine a 50-watt light bulb slowly dimming. That's kind of what it'd be like, taking hours to actually freeze something.
Hours. So there's a chance of survival, maybe even enough time for a rescue.
Potentially. But proximity to a heat source like the sun would drastically change that. You'd be dealing with the opposite problem pretty quickly.
Okay, no space selfies near the sun. Got it. But that brings us to another space myth. Exploding bodies. Is there any truth to the whole head popping like a balloon scenario? Gruesome thought, but makes for good cinema.
There is a grain of truth to this one. Fluids do boil at lower pressures. So in the vacuum of space, your saliva would definitely start bubbling. There's actually a fascinating case from 1966 where a NASA technician was accidentally exposed to near vacuum conditions in a test chamber.
Oh, I remember reading about that. It's incredible he survived.
Absolutely. His last conscious memory was of his saliva boiling on his tongue.
Oh, wow.
Luckily, they were able to repressurize the chamber in time.
That's both horrifying and amazing. But it raises an important question. What safety protocols were put in place after that incident to prevent it from happening again?
Well, for one, there's a much greater emphasis on redundant safety systems in vacuum chambers. And the incident also led to advancements in spacesuit design, particularly the development of emergency backup systems to provide a reserve oxygen supply in case of a sudden decompression. It really underscores how even a seemingly small error can have huge consequences in space.
It definitely makes you appreciate all the work that goes into ensuring astronaut safety.
It also highlights that the real killer in space is hypoxia, the lack of oxygen.
Okay.
You'd pass out in seconds and be gone long before any pressure-related issues could do any serious damage.
So no exploding heads, but always double check those oxygen tanks, right?
Yep.
Which brings us to another space myth. Asteroid belts. Movies often depict them as these dense, deadly minefields for spaceships to navigate. But how accurate is that portrayal?
Think of it more like a cosmic ghost town. In our asteroid belt, the average distance between large asteroids is vast, making a collision extremely unlikely.
So those epic spaceship chase scenes through asteroid fields are more fiction than fact.
Exactly. And it's worth noting that while our asteroid belt is pretty sparse, there are other regions that are much denser and potentially more dangerous.
Like?
Saturn's rings, for example, are packed with ice and rock particles, making them a very real threat to any spacecraft trying to get close.
And closer to home, what about Earth's Van Allen radiation belts? They sound a bit ominous.
Think of them as magnetic traps surrounding Earth, capturing charged particles from the sun.
Okay.
They can be incredibly disruptive to electronics and pose significant risks to long-term human health.
Right. Radiation is definitely a concern, but it's not just the big stuff we need to worry about. The article also mentions tiny, super-fast debris like micrometeoroids and space junk.
Those are incredibly dangerous. Imagine tiny projectiles zipping around at speeds faster than a bullet.
Yeah.
Even a small impact can cause serious damage to a spacecraft.
So it's like a cosmic game of billiards, but with much higher stakes.
Exactly. And with the increasing amount of satellites and debris in orbit, this is becoming an even bigger problem.
It definitely makes you rethink those dreams of interstellar road trips. Speaking of threats from space, let's shift gears and talk about solar flares.
Okay.
They always seem to spell doom in the movies, triggering global blackouts and mass panic.
It makes for a compelling story, but the reality is a bit more nuanced. Solar flares are primarily an electronic threat. They can definitely disrupt communication systems and power grids, but they don't directly harm humans on Earth because our atmosphere acts as a shield.
That's a relief, so no apocalyptic solar flare scenario.
Well, not exactly. There are far more powerful cosmic events that could pose a serious threat to life as we know it. A nearby supernova, for example, or a gamma ray burst.
Those sound even more terrifying than a solar flare. What kind of damage are we talking about here?
Imagine a blast of energy so intense that it could strip away Earth's ozone layer, exposing us to lethal levels of radiation from the sun. It would be a mass extinction event. Not exactly the kind of light show you want to see.
Okay, I'm officially adding nearby supernova to my list of things to avoid. But let's move on to something that's captured the imagination of sci-fi fans for decades. Black holes. Are they really the all-consuming cosmic monsters that gobble up anything in their path?
Black holes are definitely fascinating, and they do exert a powerful gravitational pull. But like many things in space, the reality is more nuanced than the Hollywood portrayal.
So they're not just giant cosmic vacuum cleaners sucking up everything in sight.
Not quite. At a safe distance, a black hole's gravity behaves just like any other massive object. It's only when you get extremely close that things start to get messy.
How messy are we talking here? Is it the whole spaghettification thing I've heard about?
Spaghettification is a real phenomenon, though the name is more dramatic than the science. Essentially, as you approach a black hole, the gravitational gradient becomes so intense that the difference in pull between your head and your feet becomes extreme, stretching you out.
Ouch. Not exactly how I want to go out.
But even before you could get close enough to be spaghettified, you'd likely be incinerated by the accretion disk surrounding the black hole. It's a swirling inferno of superheated matter being pulled in.
So it's a double whammy of cosmic doom. First you get cooked, then you get stretched.
It's safe to say that black holes are best admired from afar.
Definitely good advice. But even black holes seem almost tame compared to the truly mind-boggling existential threats our universe might hold. Things that could rewrite the laws of physics as we know them.
You're entering the realm of theoretical physics, where even experts can only speculate. But yes, there are scenarios where the very fabric of reality could unravel.
Like the Penrose-Hawking thunderbolt, which sounds absolutely bonkers.
It's a hypothetical scenario, but a fascinating one. Imagine a black hole without an event horizon, essentially a naked singularity.
Okay.
According to some theories, such an object could cause a catastrophic disruption in space-time, sending a wave of destruction through the universe at the speed of light.
A cosmic thunderbolt indeed. But it gets even weirder. There's this concept called vacuum decay, which sounds like something straight out of a science fiction novel.
Vacuum decay comes from the idea that the Higgs field, which gives particles their mass, might not be in its most stable state. Picture it like an invisible energy field that gives everything mass, a kind of cosmic glue holding the universe together. A high-energy event could trigger a bubble of true vacuum, expanding at the speed of light and rewriting the laws of physics as it goes.
So it's like a cosmic reset button. Everything we know about the universe, gone in an instant.
In theory, yes. And here's the truly chilling part. If vacuum decay is already happening somewhere in the universe, we wouldn't know it until it reaches us. It would be instantaneous and unavoidable.
Okay, that's officially the most terrifying thing I've learned all day. I think I need a moment to process all of this. The dangers of space are definitely more complex and existentially terrifying than I ever imagined.
It's a lot to take in. But before we get too overwhelmed by cosmic doom, let's take a moment to appreciate the wonder and resilience of life on Earth. We'll be back in a flash to explore some more down-to-earth dangers of space travel, including the ones that don't involve rewriting the laws of physics.
Sounds good. Welcome back to our deep dive into the dangers of space. You know, after that last segment, I'm almost tempted to cancel my plans for that interstellar vacation.
It's certainly a lot to consider, but before you swear off space travel altogether, let's shift gears and explore some dangers that are a bit more, shall we say, down to earth.
Okay. I'm all for a little less cosmic doom and a bit more practical reality. Where do we start?
Well, we've talked about the catastrophic threats, but what about the more insidious dangers? The ones that might not make for blockbuster movies, but are no less significant for astronauts on long-duration missions. Think radiation exposure, muscle atrophy, and bone density loss.
Right, it's not all about dodging black holes and supernovas. You have to contend with those everyday challenges of living in such a hostile environment.
Precisely. And one of the biggest challenges is something we take for granted here on Earth: gravity. Without it, our bodies start to change, muscles weaken, bones become less dense, even our cardiovascular system is affected.
That makes sense. Astronauts on the ISS have to exercise for hours every day, right? Just to maintain muscle mass.
Exactly. It's like a constant uphill battle against the body's natural tendency to adapt to its environment. And for future missions to Mars or beyond, where astronauts will be exposed to even longer periods of microgravity, this is a major concern.
So what can be done to mitigate these effects?
Scientists are exploring a variety of countermeasures. There are specialized exercise regimes, dietary supplements, even artificial gravity systems being developed. It's a fascinating area of research as it pushes us to understand the limits of human adaptability.
It's amazing how the human body can adapt, but also how vulnerable it is to changes in its environment.
It's a delicate balance. And speaking of delicate, we can't forget about radiation. We've talked about solar flares and cosmic rays, but there's also a constant background level of radiation in space that poses a long-term risk.
So even if you avoid those big bursts of energy, you're still exposed to a constant low dose.
That's right. Space is permeated with radiation from various sources, and long-term exposure can increase the risk of cancer and other health problems. It's one of the biggest challenges for deep space missions.
What are some of the strategies for protecting astronauts from this radiation?
Shielding is key. Spacecraft are designed with special materials that can absorb or deflect radiation. And mission planners try to minimize the amount of time astronauts spend outside of these protected environments.
But there's only so much you can do, right?
Exactly. It's a constant balancing act between mission objectives and astronaut safety.
This deep dive is really making me appreciate all the factors that go into planning a space mission. It's not just about rockets and spacesuits. It's about understanding and mitigating all these potential dangers.
You're absolutely right. And we haven't even touched upon one of the most critical aspects of space travel, the psychological impact.
You mean the whole being stuck in a tin can, hurtling through the void aspect?
Well, that's part of it, but it goes deeper than that. Think about it. You're isolated from everything familiar, confined to a small space for months or even years, constantly aware that you're millions of miles from home. That kind of experience can take a serious toll on mental well-being.
I imagine it would be a bit like being on a submarine, but on a much grander scale.
That's a good analogy. There's the sensory deprivation, the lack of natural light and fresh air, the limited social interaction. And then there's the constant stress of knowing that any small error could have catastrophic consequences. It's a unique and challenging environment.
So how do space agencies prepare astronauts for this kind of psychological pressure?
Astronaut selection is incredibly rigorous, with a heavy emphasis on psychological resilience. And once selected, astronauts undergo extensive training to develop coping mechanisms for stress, isolation, and confinement. There are also protocols in place to monitor their mental health throughout a mission and provide support if needed.
It makes sense that you would need people who are not only physically fit, but also incredibly mentally strong.
Absolutely. And there's a growing recognition that psychological support is just as crucial as physical life support for long-duration space travel.
You know, earlier we talked about the impact of microgravity on the body, and now we're discussing the psychological impact of space travel. It makes you wonder what other hidden dangers might be lurking out there, things we haven't even begun to consider.
That's a great point, and it speaks to the importance of ongoing research and exploration. As we push further into space, we're bound to encounter new challenges and dangers we never anticipated. That's the nature of venturing into the unknown.
It's both exciting and a little unnerving, isn't it? The idea that we're constantly pushing the boundaries of our knowledge and understanding, while at the same time exposing ourselves to potentially unforeseen risks.
Exactly, and that brings us to another aspect we haven't yet discussed, the sheer alienness of it all. I'm not talking about little green men, but rather the profound psychological impact of being immersed in an environment that is so fundamentally different from anything we've evolved to experience.
Now that you mention it, I've read accounts from astronauts describing a sense of awe, but also a profound feeling of isolation, even dread, when looking back at Earth from space. That pale blue dot perspective, but magnified tenfold.
Precisely. Imagine the mental fortitude it would take to venture beyond Earth's orbit, knowing that you're leaving behind everything familiar, everything that grounds you. To face not only the physical challenges of space, but also the existential weight of being a solitary speck of consciousness in an infinite void.
It's humbling, to say the least. It makes you realize that space travel isn't just about rocket science and engineering. It's about pushing the boundaries of human resilience, both physical and mental.
And that brings us to a crucial point. If we're going to venture further into space, to establish a sustainable presence on the Moon, Mars, or beyond, We need to understand these psychological challenges as deeply as we understand the laws of physics.
So we need a whole new field of study, space psychology, to figure out how to prepare astronauts not just for the technical demands of the mission, but for the mental and emotional toll of prolonged exposure to the alienness of space.
Exactly. We need to select individuals with the right temperament, develop training protocols that build resilience, and create spacecraft environments that mitigate the psychological stresses of isolation and confinement.
It's like designing a life support system not just for the body, but for the mind as well.
A brilliant analogy. And as we venture further into space, the need for this kind of psychological life support will only become more critical.
This deep dive has really opened my eyes to the complexities of space travel. It's not just about the adventure and the scientific discoveries, it's about facing challenges and dangers on a scale we can barely fathom.
You've hit the nail on the head. Space is a beautiful and awe-inspiring realm, but it demands our respect, our ingenuity, and our unwavering commitment to safety.
Well, folks, we've covered a lot of ground in this second part of our deep dive. We've explored the less glamorous but equally important dangers of space travel, from the impact of microgravity on our bodies to the psychological toll of isolation and confinement. And we've touched upon the sheer alienness of space, a challenge that will require us to push the boundaries of human resilience like never before. We'll be back in a flash to continue our exploration, but for now, take a moment to contemplate the incredible challenges and opportunities that lie ahead as we venture further into the cosmos.
And we're back for the final leg of our deep dive into the dangers of space. I have to admit, thinking about the vastness of space and all those potential dangers we've discussed can be a little overwhelming. It's certainly humbling, isn't it? Realizing we're just tiny specks in this enormous, often chaotic universe.
It really puts things into perspective, makes those everyday worries seem a lot smaller.
Exactly. And it highlights something truly remarkable about humanity. Despite our fragility, we have this innate drive to explore, to push beyond the familiar, to confront the unknown, even when that unknown might hold dangers we can't even fathom.
It's like that old saying, the greatest danger for most of us is not that our aim is too high and we miss it, but that it is too low and we reach it. I think that applies to space exploration as well. We can't let fear hold us back from reaching for the stars, even if it means facing those risks head on.
Well said. It's that spirit of exploration, that willingness to push boundaries, that has led to so many incredible discoveries and advancements throughout human history. And it's what will continue to propel us forward as we venture further into the cosmos.
But as we've learned in this deep dive, space travel is not for the faint of heart. It's a constant balancing act between pushing the limits of human ingenuity and respecting the immense power and unforgiving nature of the universe.
You've hit the nail on the head. We need to approach space exploration with both a sense of wonder and a healthy dose of caution. We need to learn from past mistakes, anticipate potential dangers, and constantly innovate to develop new technologies and strategies to protect ourselves.
It's a reminder that every successful space mission is a testament to human collaboration, ingenuity, and perseverance. It takes thousands of people working together, pushing the boundaries of science and engineering to overcome those challenges and make those incredible journeys possible.
Absolutely. And as we move towards a future where humans might have a permanent presence on the moon, Mars, or even beyond, the importance of that collaboration and that shared commitment to safety will only become more crucial.
So as we wrap up this deep dive, I'm left with a mix of emotions: awe at the sheer scale and wonder of the universe, respect for the immense challenges and dangers of space travel, and a profound sense of admiration for the human spirit that drives us to explore, to push beyond our limits, and to reach for the stars.
Beautifully put. It's a reminder that while space can be a dangerous and unforgiving place, it also offers unparalleled opportunities for discovery, for scientific advancement, and for expanding our understanding of our place in the cosmos.
And who knows what wonders and perils await us out there in the vast expanse beyond our pale blue dot. Perhaps new forms of life, new laws of physics, new challenges that will test our limits and inspire us to reach even greater heights.
It's a journey filled with both risk and reward, and it's one that we, as a species, are uniquely equipped to undertake.
So to all of you listening out there, keep looking up, keep questioning, and keep exploring the wonders and mysteries of the cosmos. The future of space exploration is in our hands, and it's up to us to shape it with wisdom, courage, and a deep respect for the universe we inhabit.
Until next time, space explorers, may your journeys be filled with wonder, discovery, and above all, safety.